All right, here we are on our very last lesson of the year. It might turn into more than one video, but we'll see how it goes. It's called the Binomial Theorem. So just a reminder, what is a binomial? So a binomial, just like a bicycle has two wheels, a binomial has two terms, okay? And terms are separated by either a positive, a plus, or a minus sign. So x plus y, or say 2x minus 3 over x. That would also be a binomial. So that's a binomial. We've been used to multiplying binomials for a while. We did a lot of this kind of stuff, this x plus y all squared. And so we've multiplied that in the past and gotten x squared plus 2xy plus y squared. Maybe sometimes we've even done this one with the cube. It's a bit of work to do this. Generally, you multiply out x plus y squared, get this, and then you would multiply it times another x plus y, and then multiply it out and you get this. And if I was to ask you to do x plus y to the fourth power, at this point you would probably roll your eyes and say, Mr. Speiser, that is a bit of a waste of time. Please, is there a shortcut? Is there a way we can figure this out faster? And that's where the binomial theorem comes in. So first of all, just for the sake of terminology, we're going to call our the first term in the binomial, we're going to call it a, and then we're going to call it b. Now I believe in the textbook they might use x and y to the nth power. We're going to go with a and b. Why is that, you might ask? Well, I'll tell you. Because here, this is a preview of what we're doing a little bit later on. This is again from the formula sheet. So look how that, on the formula sheet for our provincial exam, they like to use a and b as well. So hopefully you'll be able to translate between a and b on this worksheet and on the provincial exam questions and x and y in the textbook. So that's the first term, that's the second term. All right, so let's look at this pattern a little bit when we're looking at it. So it says with a binomial expansion. So what's a binomial expansion? That's when you multiply this out. So here is the binomial to some nth power, and this is the expansion. That's when you multiply it all out, okay? So we refer to the first term of the binomial is, and we call it a, right? And in the second term we call it b. That was just what I was talking about. The exponent of a, so what happens to the exponent of a as we look here? So let's look at this last one. Here it's in the expansion, right? It goes fourth, third, second, and now this would be the same thing as 1. How about here? Is there any x's? No, there aren't. But it would be the same thing as saying x to the 0 and y to the fourth, right? So it actually does this 4, 3, 2, 1, 0 pattern. So this one decreases or goes down by 1, okay? So I'll write the word decreases here in each term of the expansion. And the exponent b, so the second one, which in this case happens to be a y, but it is now again, this would be like y to the 0, to the 1, to the 2, to the 3, and then to the 4 at the very end. So that one increases by 1. There are always, now we're looking for a number. There are always some number of terms of the expansion where n is the exponent. Okay, so let's look at this one here. Here n is equal to 1. Here n is equal to 2, right? How many terms are there in the expansion? 2 terms. How about in this one? So when n is equal to 2, there are 3 terms. I think you see the pattern. So whenever there is if n is the exponent here, then there are n plus 1 terms, right? If this is a 4, there should be 5 terms here. 1, 2, 3, 4, 5. So there are always n plus 1 terms. Therefore, the number of terms is 1 more than the value of the exponent. Let's throw something crazy at you. So if I said x plus 2y to the power of 14, how many terms? You betcha, 15 terms, right? Okay, the next blank is the blank of the exponents of each individual term of the expansion is equal to the exponent of the binomial. The blank of the exponents. So let's take a look here. Well, if this x to the fourth is going down by 1 each time, and the power for the y is going up by each time, 4 plus 0 is 4, 3 plus 1 is 4, 2 plus 2 is 4, 1 plus 3 is 4, 0 plus 4 is 4. So I think the word we're looking for is the sum of the exponents of each individual term of the expansion is equal to the exponent of the binomial, where by exponent of the binomial, what we mean by that one is n. Okay, so again, if we were to stop along the way somewhere here, we would get x to the power of something and then 2y to the power of something, and those two somethings would always add up to 14. The coefficients are symmetric, read the same left to right. Okay, let's just check that out. All right, so check out the coefficients here. This is, maybe I'll need a new color here. How about red? This will be a 1. Okay, this is a 4, 6, 4, and then a 1 again. 1, 4, 6, 4, 1. See how they're symmetric? Like a palindrome. Here, this is 1, 3, 3, 1. This is 1, 2, 1. This is just 1 and 1. Okay, so we could say that the coefficients are symmetric and can be found using combinations. Oh, okay, so that whole stuff that we've been learning about combinations actually has an application to expanding these binomials when you multiply it out, where n is the value of the exponent. So check it out. So for x plus y to the fourth, okay, so I already investigated, we already found that here are the coefficients, 1, 4, 6, 4, 1. Okay, isn't this neat? 4 things taken 0 at a time is equal to 1. 4 things taken 1 at a time is equal to 4. 4 things taken 2 at a time is 6, and so on. Oh, okay, isn't that cool? So let's just see in this example, n is always this one here, right? Let's see if we can make a rule here. So this is called the binomial theorem. Let's write it in here. So the binomial theorem so when you're given a plus b to the power of n and you expand it, okay, if you do the multiplication out, the first term is going to be equal to n c0, which no matter what this number is, it's always 1, okay? And then we're going to have a to the power of n and b to the power of 0. Okay, so that's like this first term here. Okay, this is that's this term here. That is our in this case 4 things taking 0 at a time, and then x to the power of 4, y to the power of 0. And now what happens is that the exponents for the x are going to come down, the exponents for the y are going to increase, and we're going to follow that same pattern for the coefficients. So our second one is, I'm clearly going to be running out of room here. Our second term is this one here, so it's 4 c1. Oh, sorry, and now I want to use the generic term, so I'll say n c1. And now my power here is going to be coming down by 1, so I'll say n minus 1, and then b to the 1. I'll do one more here, plus n c2, a to the n minus 2, b to the 2. So you see how we're keeping that pattern, n minus 1, n minus 2, and 0, 1, 2. I'll say dot, dot, dot. So it's going to be going on for a long time until where it ends. Now, what would the very last one be? So if we're starting at 0 and 1 and 2 and so on, the last one, I'll write my last one here, n, c, n. So it starts at 0 and this number increases until we get up to n. And by the way, this number again would be 1. And now my a to the power of, now we're going from n decreasing down to 0, and my b would be up to n. Okay, let's go backwards one. So it's still nc, but now it's not all the way up to n, now it's n minus 1. A to the power of 1, b to the power of n minus 1. Dot, dot, dot. So this is maybe the first 3 terms, and this is the last 2 terms. Okay, so this will be our definition here of the binomial theorem. Now you'll notice It's not on your formula sheet. This is kind of a little piece of the binomial theorem. So it looks really complicated now, but with the given the piece that's on the formula sheet, it's really not so crazy. Okay, now it says expand x plus y to the third power using the binomial theorem. Okay, so in this case, n is equal to 3, a is equal to x, and b is equal to y. And so we want to expand this. So first of all, we know that there are going to be 4 terms, okay? And the first one will be 3c0. And let's just do these ones first, and then I'll have a plus 3c1 plus 3c2 plus 3c3. So now we'll fill in the inner part here, and I'll even switch to green for this. So we will have a to the power of n. Now a is x, so I'll say x to the power of 3. And now this one will be x to the power of 2, x to the power of 1, and now x to the power of 0, which is 1, so I'm not even going to write it. And now the y's, we'll start with y to the power of 0, so I don't need to write it. This is y to the power of 1, y to the power of 2, and then y to the power of 3. Now the only thing left for us to do is substituting these values. Well, first of all, anything taken 0 at a time is going to be equal to 1. So I'll say 1 x cubed plus 3 things taken 1 at a time. That's going to be equal to 3. 3 things taken 2 at a time. That will also be 3. So just remember how this works. For combinations, it's 3 factorial divided by the difference of those, which is 1 factorial over 2 factorial. So this 3 factorial is 3 times 2 divided by 2, so that would be equal to 3. Alright, so here we go. X squared y plus 3x y squared plus, I will draw the 1. This is just equal to 1, so I'll just write y cubed. I didn't even actually have to write that initial 1 either. I'll put them in there. Okay, so there is our answer for using the binomial theorem for the x plus y cubed. At this point you might think, oh, it's just probably faster for me to multiply it all out. But you'll see how robust this binomial theorem is. So I could put 100 in here and we'd be able to figure it out. Some of you may be familiar with something called Pascal's triangle. I think there's a French mathematician, Blaise Pascal. Blaise was his first name. I don't know, I kind of like that first name. Don't give her many Blaises anymore. Can you see the pattern if you take a look at it? In fact, here, just out of the blue, determine the next line of the triangle. Do you think you can do it? How about if I just start writing it and you'll see the pattern right away? Did you get it? I think you did. So this 1 always just continues. The next line is going to start off with a 1 again. And then to figure out the number that goes in between here, we add these two together. So that would be a 1 and then a 9 here. Determine the next. Find the connection between Pascal's triangle and the binomial theorem. May have jumped out at you a little bit. If you remember, if we expand this, let's say if we expand a plus b to the power of 1, we get 1a plus 1b. Okay, not too crazy. If we expand here and we get a plus b to the power of 2, we would get 1a squared plus 2ab plus b squared. If we do a plus b cubed, we would get 1a cubed plus 3a squared b plus 3ab squared plus 1b cubed. So you see what's happening here. okay, that this shows us the same pattern, okay? So how could we write our sentence here? Here's how I would recommend. I would say row. No, let's just take a look at this. This is row 1, right? That's row 1, and that would be an example for a plus b to the power of 0, which is just equal to 1. Okay, so row 1 goes with an n value, that's this, equals to 0. This is n equals 1. Here's n equals 2. Right, and so here this is row 2. This is row 3. So how could we write this? We could say row n plus 1 of Pascal's triangle contains the coefficients of the expansion of a plus b to the power of n. Okay, so if you are interested in this one here, what row would that be? This would be row 8. Okay, determine the numerical coefficient of the 6th term of the expansion of this. So you look in row 8 and say, which is the 6th term? Okay, so this is row 1, 2, 3, 4, 5, 6, 7, 8. So this is row 8. And now we want, what was it again, the 6th term? 1, 2, 3, 4, 5. Here it is. We want to use 21. So all that we're asking for is the numerical coefficient, 21. That's our answer. Explain a situation in which Pascal's triangle does not give the coefficients of each term of the expansion. Well, what if we had a was equal to, say, 2x, and b was equal to y? Because then when we would get, right, 2x plus y, let's say squared here, then we would get 4x squared plus 4xy plus y squared, right? So if one of the terms contains a coefficient in there, if it's not just an x or a y, so you know we'll see some other situations where that happens. All right, now this is the part that's on your formula sheet. So this is the one that I talked about before. So there we go. So this is for finding a specific term. So that's what the T stands for. This is term number k plus 1. So over here, when we said the 6th term, right? So it'd say, oh, well, k plus 1 is equal to 6. So it would be term 6, like that. So if k plus 1 is equal to 6, k is equal to 5, okay? So we'll see why we do that in a second. So we say term k plus 1, we use this combination and a to the power of this and b to the power of that. That's kind of neat. So you can figure out any term like that. So, oh, here we are. So when we looked at the 6th term, k was equal to 5. All right, so let's use this brand new formula here to say determine the 9th term of this expansion. Okay, the 9th term. In other words, what we need to find out is what is T9 equal to, right? So k plus 1 is equal to 9. So that means that, I'm going to write it bigger so I see it better, k is equal to 8. All right, a is equal to x. So there's my a value. B is equal to, looking over here, -2. And n is equal to 12. Okay, so using our formula here, we're going to say T of k plus 1 is equal to, I'll just write it out the first time, n c k of a to the power of n minus k and b to the power of k. So plugging in all our numbers here, we're going to get term 9, because it's 8 plus 1, is equal to 12c8 multiplied. Now instead of writing a, I'll write x to the power of 12 minus 8, which is 4, and b, which is negative 2 to the power of k, which is 8. Alright, so figuring out this 12c of 8, that's equal to 12 factorial divided by the difference of those, which is 4 factorial, 8 factorial. If I do all this work, tell you what, let's pretend it was a non-calculator question. I could go 12 times 11 times 10 times 9 times 8 factorial all over 4 times 3 times 2 times 8 factorial. So my 8 factorials disappear. I can do a little bit of creative work here and say, how about my 4 and my 3, get rid of that 12. This 2 will turn this into a 5. So 11 times 5 times 9, 5 times 9 is 45, times 11, 495. Okay, so probably this would be a calculator question, but I kind of like doing that sometimes. So 495 multiplied by x to the 4th. Now what is a negative 2 to the 8th power? First of all, it's a negative to an even power, so it's going to be positive, and 2 to the 8th is going to be equal to 256. Okay, so this is definitely not a non-calculator question because we need to multiply those two together, and then we get 126,720 x to the 4th. Okay, so if we were to expand this out, we would get 13 terms, all right? Because n is 12, so we would have 13 terms. And the first one would be x to the 12th, and the last one would be no x at all. So the 9th term would be this one here. Example number 3 says, determine the 4th term of this expansion. Okay, well, let's do the same stuff we did before. First of all, the 4th term means that k plus 1 is equal to 4. So that means I know that k is going to be equal to 3. And I know that, looking over here, n is equal to 9, a is equal to x, and b is equal to, oh, it's a little bit crazy here, this 1 over 2x squared. Alright, so our term here, term of k plus 1 is equal to nck with a to the power of n minus k and b to the power of k, and again in your formula sheet, so it's not so crazy. So plugging this in here, I'm going to get term 4, so that's 3 plus 1, is equal to 9c3 multiplied by x to the power of 6, and then 1 over 2x squared, all to the power of 3. Alright, so figuring out our 9c3, that's going to be equal to 9 factorial over 6 factorial, 3 factorial. So that would be equal to 9 times 8 times 7 times 6 factorial, all over 6 factorial times 3 times 2. So that would cancel each other out. Here I can get rid of this and make that into a 3. Get rid of that and make that into a 4. So 3 times 4 times 7, 84. So this term will be 84 multiplied by x to the 6th times, now what happens here? Well, my 2 is going to get cubed, so I'm going to say 1 over 8. Now when x squared gets cubed, remember we multiply those out, so it's going to be x to the 6th. Okay, and now we're almost done, except for I've got an x in the numerator, I got an x in the denominator, so those would actually cancel each other out. Kind of cool. So that x squared and that x squared would cancel each other out. So my answer is going to be equal to 84 over 8. So I could reduce this, maybe we could say 10 and 1/2 as our answer. Okay, so here is your homework for this section, and I will be breaking this up. I'll end this video now, and I'll see you later.